Welcome back to Make Games with No Money or Experience. In the last episode, we went over many GDScript coding basics. From this point forward, we'll be reusing many of the principles we established in the previous episode. For reused elements, I plan on restating what they are and then moving past with little explanation. If I come to something you don't understand and I don't explain it, it's likely I already explained it in a previous episode. Today we're going to go over some more button properties, the label node, and how to combine strings with integers. To start, we'll identify our primary problem. Our players can't see how much paper they have created. We also have a secondary problem. Our button increases paper once per frame instead of once per click. These problems can be approached in any order, so I'm going to dive into the primary problem first. In order to display text that the player can see, we're going to use the label node. First, be sure to have the world node selected before you add any nodes. Nodes automatically get added as children of the node you've selected in the Scene tab. We want our label to be a child of the node, not the Add button. So I'm going to select the world node. Click the Add Node button, find the label, and add it to my scene. Once the label's there, organize yourself by renaming it. I'm going to name mine paper_display. You'll notice that our label has several options that just popped up in the inspector. I'm going to adjust some of these so we can align our label box property. In the text box, I'll write amount of paper, space, space. And then some arbitrary number. How about just 100? Now I'll use the transform tool to grab the label box, make it a bit longer, and then center it above the add paper button. I'm going to want that text aligned to the center, so I'll set the alignment to center. I'll end with changing that 100 back to a 0. I only had it at 100 so I could see what a larger number would look like in the viewport. Now that it's in place, I'll change it back to a 0 so the player doesn't think the amount of paper starts at 100 when the game starts. The next step is to make this label display the actual amount of paper. For this, we're back in the scripts. This code's going to go under our add paper logic statement, but it shouldn't be a part of it. I'm going to press enter and then hit backspace, so we're no longer in the logic statement anymore. Now, I could start writing my code right here, but just to help myself out a bit and keep them separated, I'll add an extra line break between the two. Here's what we want to happen. Every frame, change the label's text to equal the description amount of paper followed by the amount of paper the player has. Okay. Since we're already in the process function and we're not a part of a logic statement, whatever we write here is going to run every single frame. So just by placing it here, we've completed that first part of the statement. What do we need to do next? Well, we need to change the label's text. So just like with the button, we'll access the label by writing the $sign and then paper display. Then, to access the text property, we write that period, like we did before, and then text. Great. So we have access to the label's text. So before, when we accessed the button, it was to check if it was in a certain state. In this case, instead of checking for the state, we want to change the current state. We do that in the same way that we changed our paper variable, by writing equal. Let's take a look at the inspector really quick, because I want to point something out about node properties. Each of these node properties has a very specific kind of variable it uses. If we look down here, uppercase can either be on or off. This is also stated as true or false, or a Boolean. Lines skipped right down here is a number, so it is represented by an integer. Text itself is a string of text, so it is represented by a string. None of these variable types play nice with each other. If you try to plug an integer into a string, you're going to get an error. So if we look at where we're changing our paper display text, we need to make sure that we put after this equal sign a string. So to do that with text, we just put it inside quotation marks. So I'm going to write amount of paper, space, colon, space. It's important that we include spaces as well. Next, we need to insert our paper variable. But as you can see, our paper variable up here is an integer, not a string. We'll need to convert it. First, we add a plus. This just means we're adding something to the end of this string. It's less of a math equation and more just to tell Godot that something else comes next. Next, we convert our integer into a string by using the function str, then a parentheses, and we can add our variable, paper. So what this will do was we'll write amount of paper, and then it will add whatever the paper variable is. So in this case, it starts with 0, but it may increase immediately after that string. Let's test to see. Okay, so we have our text, the amount of paper we have is displayed, and it changes every time we press our Add Paper button. Of course, our button still just holds down, so let's fix that. Stop the program and select our Add Button node. By default, Godot buttons have two possible states. Press mode. Every frame the mouse is over the button and pressed down, the button is pressed. If not, the button is not pressed. And 2, toggle mode. Every time the mouse is clicked, the press state changes. We need to add a third state, a clicky state, that makes it so every time the button is clicked, the button is pressed for only one frame. To do this, we're going to utilize the toggle mode, since it only checks to see if the button has been pressed on the initial click, not every single frame. So, check the box to the right to enable toggle mode. Now let's head back into our script. Let's add another property to our add button logic statement. But first, I'm going to get rid of this print paper by adding just a pound in front of it. Normally I would just delete it, but we'll leave it there so you can reference it later. Move to the next line. And now that the button is in toggle mode, we know that once the button is clicked, it will move to the pressed state, and then not take any more input from the mouse until the button is clicked again. We can take advantage of this by changing the press state in code. Start by accessing the press state. We did this before to check it, so I'm just going to copy and paste. Now, I'm going to change it, so it's not pressed anymore. We know it's Boolean because of the checkbox over here, so I'm just going to type equal false. Now, here's what our logic statement is going to do. If it detects that the button has toggled to pressed, it will increase the amount of paper by 1. Then it will toggle the button back to unpressed and wait until the mouse clicks again. Remember, this would not have worked if we weren't in toggle mode, because toggle mode changes the state based on the click of the mouse, and when toggle mouse is off, it changes the state based on whether the mouse is held down. Let's test our game. And hey, here it is. We have the beginnings of a clicker game, and it's something that someone could actually play since we can see the number increasing. but there's definitely more that we can do. For one, clicker games have auto farmers and hidden bonuses, so that's what we'll be working on in the upcoming episodes. Thanks for watching, and great work today, everyone.